You may have heard the news. China just shook the quantum and AI world with something that honestly feels like it came out of nowhere. And it's kind of an announcement that if even half of the claims hold up, could push the entire industry in a new direction. We are all used to hearing about quantum computers hidden inside labs, cooled to near absolute zeros, costing millions, and barely running a few qubits. But this time the story hits much closer to home because a Chinese research team is claiming that they've built a photonic quantum chip that already runs inside a real data center using light instead of electricity. And the performance number that they're turning out are unbelievable. They almost sound fake the first time you hear them. A thousand-fold boost over NVIDIA's GPUs for certain AI workloads. Not in theory, not someday. They say that it is right now. So let's break this down carefully because there is a real innovation here, but also a lot of bold marketing to separate from reality. What they actually built. These chips come from ChipX that worked with a startup company called Turing Quantum. Together, they announced what they call the world's first scalable industrial-grade optical quantum chip. And here's what's genuinely impressive. The hardware fits on 6-inch thin film lithium niobate wafer holding more than 1,000 integrated optical components. This is a classical photonic integration, everything miniaturized, no giant cooling rigs, and no room-sized optic benches. This feels much like the hardware that could actually live inside a rack in a data center. So the question might be why photonic matters. Instead of electrons, this chip actually uses photons, light, to move and process information. And that comes with big advantages. Photons don't heat up like electrons. They travel faster and lose less energy. They can encode information in color, phase, timing, and pathway. Data centers are suffocating right now under heat and power limits, so optical systems hit right where the pain is greatest. So this is why the entire tech world, NVIDIA included, is investing in photonics. Now about that 1,000 times faster claim. So these headline numbers comes from developer claims and from reporting in the South China Morning Post. So there is no independent benchmark, no peer review papers, and no third-party performance test yet for this claim. So here's the accurate version if you want to state that. So you should say it is plausible that photonic accelerator could outperform a GPU by large margin on a specific optimization or simulation task that map well to optical interference pattern. That is more accurate. So it is not 1,000 times faster at everything, and it is not faster than GPUs on general purpose AI tasks. And the number comes only from the developers, not external reviewers. Still, if any part of that claim holds up, it is a huge deal. How about the development claims? Are they real or are marketing only? So ChipX says that the chip is already being used in aerospace, biomedicine, and in finance, and that companies have inserted these chips into their existing racks. So that's the official story. But again, there is no public confirmation from those industries. So what I think is that ChipX might be running some pilot projects in those industries to prove the deployment and the application of those chips. So right now, this should be interpreted as China claims early deployment, but we haven't seen external validation. Still, even making the claims indicate confidence. What's actually impressive about this innovation, which is verified? First, a working 6-inch lithium niobate photonic manufacturing line. Second, over 1,000 optical component integrated monolithically. A chip that uses light-based quantum classical hybrid logic and a photonic accelerator architecture that can be clustered like GPUs in data center. A co-packaging approach that puts electronics and photonics side by side for ultra-low latency. So this part is real, and Western researcher agrees that China just demonstrated world-class optical integration. In fact, they won a major award at 2025 World Internet Conference, beating out hundreds of other companies and entities. How about the scalability and the 1 million qubit line in that announcement? Here's the key nuance. When they say 1 million qubits, they are not talking about the universal error-corrected qubits used in superconducting quantum computers. They are optical mode pathway, a kind of quantum-inspired parallelism. Still, the chip is highly parallel, stackable, and built for acceleration. Think of it as a photonic GPU cluster designed for a specific high-speed task, not a universal quantum computer. That distinction matters, but the hardware is still impressive. Why this matters for the global race? The US and Europe are pushing their own photonics innovation. We have many companies in the US, such as Google and IBM, that they are working on superconducting qubits. In US, we have also a startup that working on silicon photonics. In Europe, there are companies that working on indium phosphide, and China is clearly working on lithium niobates. But here's where the China stand out. They built a factory line, not just a prototype. So they have a full closed-loop system, starting from chip design to fabrication to packaging to testing and system integration. And their pilot line already produces thousands of wafers per year. So this is not a lab curiosity anymore, and this is a hardware platform. What it means for the next few years. If photonics continue to scale, data center could offload heat-heavy tasks, AI training pipeline could become faster and cheaper, specialized quantum-inspired chips could work alongside GPUs, and we are heading toward a hybrid future where photons do the heavy lifting and silicon handle everything else. And GPU won't disappear, but they may no longer be the only game in town. What do you think about these Chinese photonic chips and their claims? Drop your comments below and subscribe to our channel if you like this video. Thank you and see you next time.